So in lesson 97, we just discussed Pythagorean's theorem, a squared plus b squared equals c squared. Welcome to lesson 98. We are going to put that into practice in regards to measuring the distance between 2 points on a graph. Let me show you how to do that. Let's get some graph paper here. And let's just jump right in to example 98.1. So here we have a graph. I'm going to switch colors so you can see what I'm doing. And we're given 2 points, 4, 2. So 1, 2, 3, 4, 1, 2. That's 4, 2. And point -3, -2. And that's going to be here. And we're going to have a line between the two of these. All right, that is the line on our graph. How can we measure the distance? Let's say we don't have a ruler. So how can we measure the distance here when it's at a weird angle? We can't just count the squares because that doesn't work. If we did that, it'd be 1, 2, 3, 4, 5, 6, 7. But that does not account for the angle. So what we're going to do is we are going to put Pythagorean's theorem into practice and turn this into a right triangle. And we're going to do that by measuring each side. So 1, 2, 3, 4, 5, 6, 7. We have 7 units here, and 1, 2, 3, 4 units here. So we're going to drop these in as the lengths of our side. So 4 squared plus 7 squared equals c squared. Okay, so a squared plus b squared equals c squared. That's Pythagorean's theorem, and that's what we're using to find the distance or the length of this line on our graph. Okay, so 16 plus 49 equals c squared, so that's 65. We unsquare c by finding the square root of 65, and we can't find the square root of 65. There are no factors for that that can be removed from that radical sign. So the length of this line is the square root of 65. And that's as far as you have to take it. You do not have to put this in your calculator and give me a big long decimal. You can stop here. Okay, let's do 98.2. All right, so we have, here's our line, or our y-axis, and here's our x-axis. And let's see what other points we are given. All right, so we have here 3 and -4. I'm sorry, 3 and -4. And we have -5 and 2. Right there. Okay, and let's draw our line. All right, we can do the same thing here. Let's go ahead and get our right triangle. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7, 8. And I want to point out that it doesn't matter which way. You could go across the top. It would still be the same. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So it would still be 8 and 6. Whichever way you go, it doesn't matter. You'll still get the same distance vertically and horizontally. So we can drop in those numbers. 6 squared plus 8 squared equals c squared. 36 plus 64, that's 6, equals c squared. 100 equals c squared. The square root of 100 equals c. And because we know that the square root of 100 is 10, we can go ahead and pull that out. So we know the length of this line is 10. Okay? All right. So we can move on. This is easy peasy. You guys should be able to pick up on this because y'all are so smart. And we're just putting Pythagorean's theorem into practice. And it doesn't matter which side you say is A or which side you say is B because they are added. Once you square them, they're added. And the commutative property of addition says that it doesn't matter which one you put in which slot. That because they're going to be added, they're going to be absorbed into each other, and it won't make a difference. So you could put 8 squared here and 6 squared here, you would still get 100 when you added them. All right? All right, let's move on and talk a little bit more about slope. We've been using slope for a while now, and we understand what it is. We understand that within the y-intercept formula, that this m is the slope. It is what tells us the angle of the line on our chart. If we give, it also tells us, where to start with the y-intercept point, and then how to draw the line by looking at the slope, how far up or down to go, and then how far to the right to go, and until we get to the next point. What we don't always have is the reference to get to slope. We're given points, but no graph to look at, and sometimes we just want to be able to look at a series of points and calculate it. It is possible to do that without having to graph the points. So that's what we're going to talk about right now. And I'm going to give you an illustration so that you can see it as I do the math and trust the result. So m is slope, and it is defined as y over x. Technically, it is defined as the change in y over the change in x. And all that means is the distance it travels on the y-axis in relationship to the distance it travels on the x-axis. That's all it is. But we have a mathematical formula for that, and that is y1 minus y2. And y'all are familiar with subscripted variables at this point. x1 minus x2. So you understand that this is just a designation for the same value in two different sets of data. Okay, so here is our graph. Okay, and I am going to give you, let's do 98.3. And our point, let me switch to green. Our first point is we have -3 and 4. And we have 5 and -2. Okay, so we are going to graph those points just for a visual. So -3 and 4 and 5 and -2. Okay, those are our points. Now, we could look at those points and count, and figure out, okay, how many from here to here? Well, if we did that, we'd have 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, 8. That'd be 8, right? So the change in y is 6. The change in x is 8, and that would reduce to 3 over 4, correct? So you could do that and you could count. That's perfectly fine. That's the way we've been doing it. We've been starting at our y-intercept and counting until we get to the next point. There's another way to do that, and this is the formula that tells us how to do that. So what we're going to do is designate any one of these points, it doesn't matter, we're going to designate one of these as 0.1 and one of these is 0.2. And I'm going to pick this one just because they're in order 1 and 2. This is 0.1 and this is 0.2. Okay, so this is 0.1 here and this is 0.2. Okay, so we're going to take the y value of 0.1 right here and the y value of 0.2. Okay, so you see how that works? These are the y's when you write your coordinated pair. So we're going to take the y value of 1 and the y value of 2, and we're going to put them on the top. So the y value of 1 is 4, and we're going to subtract the y value of 2, 0.2, that's negative 2. So when you subtract the negative 2, it turns into a positive. All right, we're going to do our x values. The x value of 0.1 is negative 3 minus the x value of 0.2, which is 5. Okay. All right, so we have 4 plus 2 equals 6. And negative 3 minus 5 is negative 8. Well, we never have the negative in the bottom. We always move it back up here, right? But let me ask you a question. Doesn't this line slope downward? And isn't that a negative line because it slopes downward? Yes. So it is correct to have a negative 6 over 8, which equals a negative 3 over 4. Now the only way to get that by counting is to look at the slope of the line and then add it later. If you do the math, it's built into the answer. So you don't even have to look at the chart and see which way the line is sloping. You get that from doing the mathematics with the point information. You can even pick this, I'm going to just change the color to red. Let's say that we want to pick this 0.2 and make this 0.1. Will it still work? Well, let's see. All right, the y value for 0.1 now is going to be negative 2 minus the y value for 0.2, which is 4. Okay, and the y value or the x value for 0.1 is 5. And the y value or the x value for 0.2 is negative 3. Again, subtracting a negative makes it a positive. So we end up with a negative 6 over 8, negative 3/4. It's the same answer, and it is a negative slope. And it was a little bit faster than drawing the graph and then counting the points and then seeing whether it's a positive or negative based on the direction of its angle or slope. But that is how you would determine slope, just by being given points. So let's try to do this without being given a graph to look at. Let's just do some points. Let's do, all right, that was 98.3. Was also illustrated with a graph in 98.4. So let's see if they give us, here's a different one. We'll do, all right, here's 2 points. We are given, all right, let's see the points from the earlier problem. Let's do negative 5 and 2 and 1 and negative 3. Okay? And then we'll graph it after we're done and see if we're correct. All right, so let's say this is 0.1 and this is 0.2. So the y value for 0.1 is 2, and the y value for 0.2 is negative 3. So that's negative 3. Now the x value for 0.1 is negative 5 minus the x value for point 2, which is 1. Okay? So we have 5 over negative 6, or a negative 5/6. Okay? Now let's reverse. Let's say, okay, this is point 2 and this is point 1. So the y value for, and this is a good way to check your work and make sure that you did your math here correctly, is to just swap the points around. So now the y value for 1 is negative 3 minus the y value for 2, which is 2. And then the x value for 1 is 1 minus the x value for 2, which is going to be a negative 5. We have negative 5 over 6, which is the same thing that we got when we swapped the points the last time. So that tells us that our math was correct. When we reversed it, the change in y is a negative 5 over 6. And we know that it is always, the negative is always affecting the y. It is not affecting the 6 or the denominator. Remember, we've talked about that before. The negative is always in the numerator, and that ties back to slope, because you never have a backwards motion of your x. It is always to the right. The only motion that changes is the y, and it can go up or it can go down, and when it goes down, when it's negative, and we call that a sink versus a rise when it goes up. Okay, and that is all we have for lesson 98, is just how to find the distance of a line on a graph using Pythagorean's theorem, and how to find slope of a line using mathematical formula instead of counting it on your chart. However, as I said we would do, let's go ahead and graph these 2 points just so we can see if we're right, right? We did it mathematically. Let's make sure we're good at what we do. So I'm going to draw this out, and I'm going to switch to green, and I'm going to graph our first point, which was negative 5, positive 2, right? So 1, 2, 3, 4, 5, and then positive 2. So that's that. Okay, and our second point was 1, negative 3. 1, 2, 3. Right, okay, so it is a negative slope because it's down from left to right, so that's correct. And let's see if we can count. 1, 2, 3, 4, 5. Okay, so that's 5. Let me get this. There, that's 5. And 1, 2, 3, 4, 5, 6. And that's 6. That's what we had. We had a negative 5 over 6. Very good. So you can see that the math works. So now you can trust it. All right, that's truly all I have for lesson 98. I will see you in lesson 99. And after lesson 99 will be lesson 100. And after lesson 100, we only have 20 more lessons and the book is done. You guys should be proud of yourself. You've done a lot of hard work this year. I'll see you in lesson 99.